Welcome to the e-learning module on Data Logger. Today we will go through the information regarding the importance of a data logger and its features, its functions, important parameters, how we install a data logger, the precautions to be taken during installation, and other things related to the National Hydrology Project NHP. So what is a data logger? The data logger is the heart of any hydrometeorological monitoring system. It performs various functions in the system, which includes sampling, acquiring the data at specified intervals, storing the data, maintaining the system time, providing the trigger for data collection and transmission, providing power supply to the sensors, providing the data to the transmitter, and responding to the user's queries either through telemetry or on-site. Now, with this basic application, data loggers are available with various features, like some having inbuilt display, some having keypad for programming. The modern data loggers have USB ports for transferring data, Bluetooth, Wi-Fi capabilities for communication with mobile devices, ports for communication with different types of sensors and telemetry devices, and power management capabilities. This complete system, which is commonly housed in the environmentally protected enclosure, also called as real-time unit (RTU) or data collection platform (DCP) or simply data logger. In some stand-alone systems, the data logger is an integral part of the sensors itself. Nowadays, few data loggers are available with inbuilt telemetry capabilities. This figure shows data logger device with battery backup mounted inside the enclosure. This figure shows typical data loggers of various kinds. This figure shows an instrument where the data logger and related instruments installed inside the box on the data collection platform DCP, whereas this figure shows a complete DCP with the INSAT transmitter attached to the data logger. This figure shows an instrument where the data logger and the shaft encoder are an integral part of the system. Actual site photograph of data logger showing readings. Here we can see actual reservoir level of that particular date and timing. Photograph showing indigenously developed data logger connected with actual temperature sensor and showing reading. As of now, we have seen various models of data loggers. Let us understand how a data logger functions. Most importantly, it supplies power to the sensors, reads and records data, and passes on this data to the telemetry unit for transmission. Secondly, it is configurable based on the requirements and provides recording intervals for individual sensors and parameters. It has a multitasking operating system, enabling it to log and transmit data at the same time. It has a digital display for monitoring current data and setting values as well as monitoring battery voltage level. Lastly, it has an internal battery backup for the clock. Now, after understanding how a data logger functions, Let us understand what important parameters we should consider while selecting a data logger for our organization. Firstly, we should consider the number of input channels provided in that model and the types of input channels, whether they are analog or digital. Secondly, what is the sampling interval? What is the resolution and accuracy of the system, and most importantly, its output compatibility? The choice of data logger and its features depends on whether any additional sensors or telemetry devices need to be added to the system in the future. Now, in order to protect our instruments, we need to take some precautions before installing a data logger. Protection from water. Data logger batteries should be located well above the expected high water mark to ensure that sensitive instruments are not submerged. Lightning protection. Each station shall employ a grounding system that will protect the electronic equipment from electrical surges caused by lightning. The system will consist of a single point grounding system which will tie all grounding wires to a copper grounding plate. The plate will then be connected with a copper grounding strap to a grounding rod. Antenna cables will utilize polyphasers to protect the DCP from lightning damage. Enclosure and wiring specifications. Instruments should be secured inside the instrument shelter in an orderly fashion. All wiring and cables should be well organized and clearly labeled and secured. The enclosure must be sealed and secured in a NEMA type 4 enclosures so as to prevent water and insects from entering the enclosure. Wires leading in and out of the enclosure must be properly secured and protected from sharp edges. The power supply and the management system should be supplied to each station that has provision for charging batteries using solar panels. The system should use a charge regulator to maintain the charge of the battery and extend the life of the battery by not overcharging it. The battery should be sealed, maintenance-free, have a standard voltage rating, easily sourced and replaceable.